5+ years of experience working around different industries, retail, banking, and other enterprises. So today I'm walking through a project that is called the AML Compliance Agent. This agent is not meant to be an other chatbot demo. The idea is different here. The idea came from an actual problem. So the idea is, can an agent sit on top of structured data, which is transaction data, and unstructured data, which is like policy documents, and answer specifically three things that you're seeing on the screen: what happened, why it matters, and um, where does the policy support? So before going deep dive into the problem statement and solution, I want to give some context. So I had the opportunity to work with one of the largest banks in Canada with their core AML team as a data engineer. My role was not primarily to act. For more context, AML stands for anti-money laundering. So my role was not to be a AML analyst, but to provide the foundation for the AML team for their reviews. Their team needed historical customer transaction around different channels. For those who haven't worked on banking, channel looks like, let's say you do an ATM transaction, that's a channel for the business. If you do a point of sale payment, that's a channel for the business, etc. Like for example, you do an online banking, wire transfer, any branch activity. So the request was simple. Like we had a typical multi-year look back window in which all of the transactions of a single customer needs to be sent over to FinTrack, which basically does which is mandatory for banks to do auditing purposes. So when I started talking with the business and try to understand the requirements on how does their data look like, a typical analyst, AML analyst, uh, it threw me off guard. What surprised me was the lot of review process that these guys do still depended on Excel-based workflows, such as macros, like formatting expectations, uh, and also like uh, mostly like, let's say there is a column that needs to be a string and it's a number. Even a simple column in the Excel change would break the whole workflow they had in place. And also it depended a lot on the analyst who worked for that bank's knowledge. How well does he know the policy to determine whether this is a compliance issue or a violation? So I found a problem there that the data existed and the policies existed, but they were not in a centralized fashion and there were no explainable workflows. So that problem inspired to me to build this demo, like use Databricks, Delta tables, RAG, text to SQL, and a router style agent to bring transaction evidence and policy reasoning together in one grounded answer. The title which says Beyond Chatbots is also very intentional. In compliance and AML, a fluent answer is not enough. Like just a data to show that this might be a violation is not enough. The answer need to be grounded in data and connected to the policy, and then it should be auditable back. If they backtrack, they should find that this is a compliance issue or a violation. So to see why it matters, let's start with the gap compliance and what teams deal with every day. So in many regulated organizations, both the half you see on the screen of the puzzle already exists. On one side, there is structured data, which sits in a lakehouse or a warehouse architecture, which is like customer information, transaction history, let's say risk rating, which is created by the ML team, wire transfers, cash deposits, channel activity, and a lot more. On the other side, in the background, there's also policy documents which the bank creates for their policies, and also what is given by governing authorities to the bank, like AML policy, there the bank's regulatory guidance, internal procedures, sanction rules, thresholds, a lot of definitions which are specific to a bank, and reporting obligations. The problem stands where these two worlds are often separate. Uh, and if there's a dashboard, let's say there's a dashboard and which has all these AML compliance issues, it cannot tell, it might show that this is the problem, like something happened, a cash deposit crossed the threshold, a wire went to a risky destination, or multiple transactions occurred in a short period. But the dashboard usually does not explain the pattern which matters, and also does not quote the policy which applies. The bridge is often manual, like inspect the transaction, search the policy, interpret the clause, and write the explanation. So the problem is not only the detection, it's also explanation and traceability. So the basic question becomes, can we give the analyst the transaction evidence and the policy reasoning together? Uh, so before I explain how I built this and what's the architecture behind it, let me be precise of what I built. This is a working compliance prototype on Databricks. As I told you, it brings two separate capabilities where the data sits in Delta Lake, and the other side we retrieve policy documents using RAG. The compliance agent that I built sits in between them and decides which capability is needed and combines the results into a grounded response. What you see on the slide is the exact agent output that of what I built. The agent can tell us what happened in the transaction data, why it might be a compliance concern, and how is that reasoning supported in the policy. I'd say that the examples are synthetic, but they represent the real world patterns that I saw closely working with the AML team. So the key point is not just that the agent produces an answer, it contextualizes the operational of data and then supports it with a regulatory clause and makes it auditable. Moving on. So at a high level, this is the architecture, and it is intentionally very simple. I'm not including any technical jargons over here. Uh, it's as simple as you see on the screen. Like a user asks a question, and that question goes to the compliance agent. Now, the compliance agent decides which capability is needed. Is a SQL capability needed, or a RAG capability needed, or sometimes both? So the final response combines here with both the transaction evidence and the policy context, however the question is routed. Now, the important distinction comes where that the LLM is not the database and it's not the policy source. Here, the SQL queries that we provide uh, has a grounded access to structured data. RAG provides grounded access to the unstructured policy data. So the LLM just provides or coordinates the workflow and explains the result. A simple way to maybe say it is that the LLM coordinates, and the tools perform what they're supposed to do, and they produce auditable results. Uh, so that is the architecture over here. I will zoom into each tools one by one. Like let me start by zooming into the RAG tool. Uh, so, so here RAG is built from scratch. So let me first explain how RAG flow works here and how I built it. So let's say the policy document exists in a source. Now the policy is consumed using libraries, and then the PDF is parsed. So considering the policies in a PDF, it is parsed and split into smaller chunks. Because the data is synthetic here, and the policy I created is maybe a 10 or 15 page document, it is split into chunks. Now, for the size of the document I have, it produced 44 chunks. Each chunk is then converted to a embedding using a BG large N model, which is a model that produces a 1024 dimensional vector. What happens when a policy when a question is asked? So let's say there's a policy user asks a policy question. The question is also converted to an embedding because the embeddings that the policy PDF is there, that needs to be compared with the um, uh, like embeddings of the question. That's what happens. So I'll compare the embedding stats out of the question vector and then with the policy vector. And using cosine similarity, I find the most relevant chunks. The important point here is that LLM does not receive the entire PDF. It receives an only small number of chunks that are most relevant to the question. And those chunks are added to prompt as context, and the model is instructed to answer from that context. So this makes the answer more grounded and also lets me return a supporting policy clause. Uh, but there might be a question that RAG can lose context and does not guarantee correctness by itself. If retrieval brings back the wrong chunk, then the final answer can also be wrong. So retrieval quality and citation validation are as important. So that's the reason I intentionally implemented the steps directly than hiding them behind a framework like, let's say, LangChain or any other frameworks available or a managed vector store. For this build, I wanted everything to be visible. So parsing, chunking, embedding, similarity search, retrieval, and generation. So with only 44 chunks that I have, and in-memory retrieval is enough. So we might think, oh, why there is not a vector database? For a small PDF, like one PDF where we are dealing only with a single use case, we might not need a vector database. That might be an overkill. So if this solution grows to a bigger level, then I would definitely consider using a governed vector search like a Databricks AI search or other vector databases like VB8. So moving on, now that we talked about how RAG is built from scratch, I'll also throw some light on how a SQL agent is important here and how does that play an important role. So this is the text to SQL part of the system. So the model writes SQL, but a guard decides if it runs. So you see that line on the PPT, right? So this means that, let's say a user asks an ad hoc question, such as, let's say, how many wire transfers went to a destination country, let's say one country. So the analyst should need not know the exact table names because he might not be familiar with Databricks. He's not a actual SQL person who understands all of this. So he might not even know column names, SQL syntax, or even how to use Databricks. So in the tool, the schema is read live from the Unity catalog and provided it is provided to the model along with the user question. So the model generates one SQL statement. So I guess all of those you who have used like ChatGPT or Claude might know generating a SQL prompt is as easy as, just give a question and give you a prompt. But the problem is we underestimate the context that we are asking the question in. So for that, for that, we have limited this with a lot of guardrails. The generated SQL query is treated as untrusted until it passes validation. So for that, I've added guardrails, which allows only read-only statements like select, or let's say it has a multi-step query with a CT, so it can begin with. So that's those are the kind of guardrails that have been added. Like also for an example, I added one guardrail which says that any other statement other than select, like insert, update, delete, these are forbidden, and I add it as a rule to the while passing rules to the LLM. So that being said, that would provide us reliable SQL statements, which can be then selected on the table and produces a readable chatbot style answer. I'll show you when we go to the demo. So uh, moving on, as you see here, Unity catalog table exposes the live table structure. One statement is generated and only select or with is allowed to execute. So this is the core. This slide covers, like, if one question is asked, uh, how are the four possible paths, which is if it's a known violation, if it's text to SQL, policy lookup, or SQL plus RAG, which route does the agent take? So this is a major distinction from a normal chatbot. So every question need not be a generic prompt, right? Like the whole point is which question should be routed to which tool is the most important. So let's say a broad compliance review question like, are there any violations? That the Are there any violations in the past 24 hours? So this type of questions are standard reporting concerns in an AML team, and that should go to a fixed violation sweep. And a question about a transaction count. So that is an exploratory question which an analyst might have, and that should go to a text to SQL tool. And a question about a policy statement. Let's say, what's the structuring policy around transaction limits of 10,000 or more? So if a user asks this question, that should be routed to a policy lookup. So uh, providing context and routing is the main job of the agent. So in the code, the agent has registered tools such as violation sweep, text to SQL, and policy lookup. The router asks the model, like, to classify users' intent and choose the appropriate tool. The top level agent receives the question, calls the router, and dispatches the selected tool and returns the answer in a chat format. So the model's value here is not that it answers everything directly. Its value is like choosing the right workflow. Uh, the tools that we have defined here do the grounded work, and the agent coordinates all of this experience. And uh, that's the whole point of this agent. Now, one distinction I would say is this is it might look like, oh, it's very simple. It has only four tools or three tools with a routing agent. But because this is a single step router, as the solution or the agent advances, this might be turned into a solution where we have a multi-step agent which calls the SQL to inspect, calls the RAG and validates the evidence, and also iterates. That's the multi-step agent that we are actually seeing today. So that is the core idea. So before we run to the demo, I want to quickly show how a control data set is behind it. So for this demo, I completely used a synthetic data set which has 100 customers and 10,000 transactions. I included known scenarios such as a CTR threshold case, a structuring pattern, and sanctions. I'll explain each of it. What does that mean and how does that relate to what's there in the policy? So because like you guys might ask a question like how does this validate with all the AML complexity and all the scenarios that are there in the world? No, that's not what I'm trying to do. I'm creating a controlled environment in which I can test the mechanism in which if this agent works. If I have planted violations, I can test them and iterate around them on how the agent works. As we know, it's like if we think about any of the models today, it's all about how well we train them to a specific need, provide them context, and make them use less tokens. It's all about that. So that's the motto here. That way, it keeps the experimentation safe. Also, there is no real customer data or any sensitive data involved. That way, experimentation is safe. Okay, now it's the demo time. Just give me one moment. I'll pull up another screen. All right. I hope my screen is visible.
Yes.
Okay, cool. So as you see here, this is the agent I was talking about. So as simple as that, it says ask a question, and the agent routes it to one of the three tools: violation sweep, text to SQL, and policy lookup. Let's ask a simple question like are there any compliance violations? I hope the screen is visible on this zoom in a bit. Yeah, so as you see, it says Rotor chose its violation sweep. It says ran the fixed pre-written detection queries and attached matching policy clause via RAG. So it says after reviewing that recent transaction, I have identified potential compliance violations in three areas. I told CTR, which is a currency transaction reporting, structuring, and Office of Foreign Assets Control sanctions. So it says this with this transaction ID, so and so customer has deposited a cash deposit, so it exceeds this threshold. Now, this is something we can easily find out. Like whoever has experience with SQL will say, "Oh, I'll write a SQL query and find this out." But it's already also giving the policy clause. It says the policy clause 2.1.1, this transaction should be reported via the CTR within 15 calendar days, which is actually in the policy rule. Also, it says there is a structural violation involving so and so customer with the total amount of this. So it says like he added multiple smaller deposits over several days. So, which means that this person, whoever this customer, he added a 5,000, 5,000, 5,000, or 8,000 over multiple days, and that's a structuring violation, and it needs to be reported. Now, this definitely like for us who are data engineers, we'll write a simple SQL query and find this out. But the whole context here is linking this to the policy documents and finding out that this is a violation is the reporting concern rather than just finding the SQL. All right. So if I say, let's say that, show me any structuring activity, what will it do? So it says run fixed predetermined detection queries. I'll show you how that does look like, and also show the behind the scenes how that agent is called in a short while. But based on, it says provided data, the structuring activity is detected for this individual. And you see these details, if you see these details, it's just a select query. Select these columns from this table where it the total deposits exceeds this amount. So okay, we are counting the total amount. So it's a count of group by adding those concerns and then creating returning these columns with from that table. Or we might join 3 4 tables because there's risk rating, which is another table, and number of deposits are holded in another table. Fine, that's fine. Now this also says, this is a structuring violation, which is because he has done multiple transactions in a span of these days. So that's what this agent does. Okay, let's try to see if we can ask it an ad hoc question and see what it returns. Uh, how many wire transfers went to each country, and which of these, like let's say one of the VP asked this question in an ad hoc call to the team, and with this, if this works ideally, even even a business person who does not have any coding experience will be able to just look at the data. He might not understand the mechanics of it, but definitely he'll be able to answer the question asked. So if you see here, it says, it also gives the generated SQL query. How many wire transfers went to each country? Which of those are sanctioned? So it says, based on the query results, here's the breakdown of wire transfers by country and sanction status. Total wire transfers by country. It says Singapore, Germany, France, Iran, UK, Switzerland, Canada, Japan, Australia, and Netherlands. So out of all these countries, it says only one country is sanctioned, and one out of which there's only one transfer, which is a sanction. So we have we have the generated SQL query, and it referred the policy that Iran is a sanctioned country under this policy, which is again synthetic data, point to be noted. But yeah, so it contextualized the policy document behind it, and then interlinked these both and gave a, 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 a response in NLP, which any layman can read and understand. Let's try to ask one more question. What's the average deposit for high risk customers and low risk customers? Yeah, so again, it just generated a SQL query with average amount, joining the compliance data with customers, and then seeing if their risk rating is low or high, and transaction type is cash deposit or check deposit, and giving a response. And this is just text to SQL. And here, even though it is text to SQL, it need not, for this question, it need not uh, consent the policy document, because it's a straight up SQL question. So that's the routing agent's job, whether to decide if it has to go through the SQL agent, or it has to take the route of like just drag using the policy, or both. Uh, let's ask a policy question and see if it does both. If it does a violation, or I mean, like, it does a just a policy lookup, or does it go for SQL as well? Oh, so I asked how long do we have to file a CTR, which is a currency transaction report. So it says that according to so and so policy and section this, it is 15 calendar days from the transaction days to file a currency transaction report for transaction involving only more than 10,000. So for this question, it's just looking at the policy. So the routing is working. Uh, yeah, I will I just want to go back to the PPT and then come back to this demo and show the how the actual code works. Give me one moment. Let me just reshare that screen.
Siva, I think you're on mute.
Oh, sorry.
No worries.
Yeah, so since I just went through a detailed demo, I'd like to take some time to reflect on what were the uh, hardest parts here, while what I learned during this process, and also after the end, I'll just walk through the code and how this is built and showcase. So the biggest lesson from this build is that generation is easy. It's not the hardest part. The harder part is deciding what the model should control and what should remain deterministic, while uh, what should be ad hoc and what evidence must come back with an answer. So first, routing is most important than prompting. So different questions need to be routed to a different tool. Like some might need SQL or RAG for policy questions, and if we know that this is a reporting concern for every day, that should go into fixed tools or violation sweep. So that is the big first lesson, that prompting is routing is more important than just prompting, because prompt can be set to the LLM and context is also can be set, but which one to route at what point is more important here. So the second one I realized. So when I started building this, I thought, okay, so the SQL agent will just return the SQL and it might not interrelate to the answer which LLM provides. But once I started building it, it hit me that evidence also must transfer, like travel with the answer. It's not just the answer that this is the violation, so that the user can see both the actual what's the violation and how much, why did this lead to a violation, so that it supports the conclusion. The third thing that I learned is rules and agents serve different jobs. So which means that there should be uh, deterministic rules on what must be done and what should not be done. For example, now, if I don't have a rule saying that SQL agent should not insert, update, or delete, and a question, like, for let's say I ask a question in a certain way and another guy asks a certain way, that if there are no guardrails, then it might insert some records or it might delete some records. So that's why deterministic rules are very important, and this should be an iterable process where it is tested and tried and proven and repeatable. Also, text to SQL is only useful for ad hoc analysis, not for controls. I mean, like not about controls, but not for a regulatory reporting requirement that every day there should be a report sent to FinTech, or every month there should be a reporting FinTech. That's not the text to SQL part. It's just about ad hoc analysis and finding new patterns, because AML is about all about finding new patterns, how violations happen. The fourth one is prompts are not security boundaries. The real controls are SQL guards, approved table access, Unity catalog permissions, execution limits. So so all these are guardrails, because the LLM does not however we give a context. Let's say we give a context that you are a so and so age and do this, but that is very limited to it, and it can, as we know, it can hallucinate, it can create new context for itself. So having the guardrails on our hand, which is like, let's say I'm using Databricks today. So the whole point is how much of a table access I'm giving to this user. Like if they are guarded by service principals, how much of a access I'm giving to these service principal, to what table, to what rows, what columns. All these come into context. And uh, so the last one is just a text fluency is not correctness. One thing I realized using LLMs is it can produce results which are wrong and show them as confidently as the confidentest kid ever you have seen. So that's how LLM works, right? Like even they if people who see Instagram might relate to this, that there was a dumb question asked to LLM, like, is it better to go to a like a car example where my car wash is 300 meters away? Should I go by walk, or should I go in a car? And the LLM provides, it says that confidently that you go walk because it's just 300 meters. So it can hallucinate. So it's about validating those and then putting it into the system so that our goal is achieved and it's not gone wrong in the midway. Yeah, those were the lessons and hard parts that I understood while building this. Moving on, uh, so these are the limitations that I witnessed, or I feel as of today. So no out of scope handling, and it's single shot routing. So what I mean by no out of scope handling is, let's take example of I asked the SQL, I asked the LLM that what are the violations that happened between exactly this date and this date. Now, I did not introduce any parameters in between, so it might not produce exact results, which says, oh, between June 15th and July 15th, these are the transactions which look like violations. So that's something today out of scope, and it's definitely a single shot routing, which means that it chooses one top level path and does not yet reason across multiple steps and iterate. So that's something which is because of the fixed detection rules. That's something a limitation today, and definitely hard-coded detection rules. I don't say that's a limitation, but I have to think around what can we do to. Definitely, there will be hard-coded detection rules, but if there's a way where we can parameterize them and make it fit to all use cases than just a single use case, that's something a limitation. So one thing I'd be definitely working on uh, towards is like, if there are more documents, we can't just use an in-memory retrieval and send it to RAG. So it needs a database to store those embedding to a vector database. So I'd maybe use a Databricks vector search, as all of the solution is integrated with Databricks. It will be easier. And uh, text to SQL allowless plus retry, so that if something is wrong, the multi-step agent will take in place and then try to contextualize and give the answer. Also, if this might be a wish list, I would say, but real-time monitoring, if there's a streaming data and monitoring on those by using this agent is something I want to try. One more thing is something like integrating this to a Genie so that it can be like right now the demo you saw is on a just a UI based Gradio app, which will let me build for free. So I use that. But the idea is to create an app, Databricks app of it and integrate in inside Genie so that once we call this agent, it'll be easier to chat with like with for any user. Moving on. Yeah, so this is built on Databricks Mosaic AI. These are the models I used and Delta Lake and Unity Catalog. And these are the libraries, which is MLflow deployments and PyPDF for parsing the PDF and the ML deployments. So as the uh, solution grows, I would revisit those and replace. As of today, because everything for me, this is a learning and experimentation piece as of today. So I use Databricks as it's easier to integrate with everything. And as the solution grows, I would definitely revisit those and hand built. And instead of using a hand built RAG retrieval function, I would use a framework which LangChain or LangGraph provides, and maybe or better frameworks which will be appropriate for the solution. But yeah, so that's the end of the presentation. I'm open for questions.
I think we have some questions in the chat. Siva, if you're able to see the questions.
Just give me a moment. I think we have a hand raise. Asim Siddiqui. Sorry if it's me, I'm not audible.
No, you are. Asim, you can unmute yourself and you can ask a question. Jean?
Yes, thank you, Siva, for the presentation. So much information. I've learned a lot. And I have a question regarding the the text to SQL query, SQL querying. So, what is the rate of chances that what you get as a SQL query is matching what you wanted to actually request, because some people who will be using this tool are not able to write SQL queries. That's one. And second, how do you know that the output query is the query itself is actually optimized? That's another question. And my third question, and when you run the query, now you said there's a rack part in the processing. That means the request goes to the internet. So how do you make sure that the request is secure? How do you make sure that the query is not going to retrieve, instead of maybe 20 rows, it retrieves 200 million rows, which will end up costing a lot of money to the company? Thank you for your answers.
Makes sense. Yeah, yeah. I'll take one at a time. So first is that when we talk about the text to SQL agent, like any agent, like we are providing context to an LLM and saying, okay, so text to SQL agent, you have these and these as responsibilities. We'll give the prompt for it, and now just giving the prompt, what will it do? It will create the SQL query. Now, just on the SQL query, that's not enough for it to get records from the database, right? So now for that, I would have to link the Unity catalog tables to it. For that, what I've used is I've linked it to the information schema and provided parameters where I say, oh, query this table based on the question and return a response. Now, coming back to that, how does this stop from saying that, oh, this is not correct or this is so? As I told, I have guardrails to uh, said that give me only a select query or a with clause, which means that I avoided all the CRUD operations by default. Now, after that, there are concerns on whether the generated query is the right data. For that, we are having validations, manual validations, which come in place and say, oh, if the question is in this context, is it querying a fixed table or a random table? Because random table does not exist in the actual what is it called, the Unity catalog tables. It would not get a response, and that's the guarding we are doing over there. But having said that, this is at a very primitive level in terms of security. I'm not a expert in security, so I would have to relook on how this can go forward and how can enterprises use them, uh, trusting trusting them. Oh, this produces a reliable response. Because as of today, in enterprises, what are they doing? They never give access to their databases to an agent at this level. They just limit it, like maybe, let's say you're using Claude or else GitHub Copilot. What we do is we generally stop at generating the code. We never link with this with the actual database. That's what I'm trying to experiment and see maybe if we can have that done with security constraints enabled with the service principles and Unity catalog in place. But I definitely believe it's a long way to go. I hope I answered your question.
Yes, thank you.
Yeah.
We
Okay,
have more.
sorry, John. John, go ahead.
I would
You're
say
saying
I will
something?
have more questions, but I will let other people go first.
Sorry, I didn't catch you.
I would say I have more questions, but I will let the floor to the other
Right,
participants.
right, yeah, yeah. So I see a question. How does the fixed sweep work since it doesn't generate any SQL query? Where does it look for the information? So fixed sweep is nothing but fixed sweep is something which comes into play where we have a known, like in AML or any, for that matter, any reporting. We have a fixed set of things that we do on a daily basis. Like for the examples I placed in, we have fixed queries uh, like CTR is a pattern, structuring is pattern, OFAC is a fixed pattern. So how can these patterns be identified, because we are not using any text to SQL agent or in there. So for day-to-day basis operations, we definitely need to have a fixed queries. Actually, that's a good question, Asim. I have a slide dedicated to that. Let me just go to the next slide and show it to you. So if you see, this is what fixed sweep is. So like in regulatory and compliance things, some things are fixed. We cannot reinvent the wheel when we already know that these are definitely mandatory things that we need to do on a daily basis. So for those queries, I have fixed queries. So I've honestly, they are deterministic, which are fixed sweep. So uh, we have the table names fixed, and we have what is the actual join between the tables fixed. So that's how a fixed sweep works. Now, what the routing agent does is it will call the fixed sweep agent tool and also the policy RAG tool, so that it interpolates both the data and gives a NLP type chatbot style response to the question asked.
Okay, got it. Can you hear me now?
Yeah, I can hear you now.
Okay, so basically, so you have prefixed SQL queries
Queries,
in
yeah.
your model.
Correct.
Okay, makes sense. Got it. Thank you.
Okay, so I see a few questions. From Lucy, can you explain why the RAG has no lang chain or no vector database? So I think I already answered this question, mentioning that because of the size of the use case where I need not hide this behind a framework, which is LangChain, uh, which does all the hard part. But uh, since this question is asked and also how that does work, I'll just walk through the code base that I have. Give me a moment. Let me share that. Screen. Okay, is my screen up? I think so.
Yes, it is.
Yeah, so if you see this, everything is built from scratch. Like uh, I call the policies. I have the policy stored in one of the workspace because it's a single policy document, and I do chunking and split the text, and then call the Databricks ML model and produce chunks. And then because it's just 44 chunks, there's no need of storing in a vector database. This is too less of a concern for a vector database. So I just store it in memory, like it's like in memory when it runs. And then we have the cosine similarity functions, which compares both the embeddings. Like once the question comes, it is embedded as well with the PDF embedding and with cosine similarity. Both of these are compared and a response is given out using the LLM. That's what has happens where we use the cosine similarity and the text both, um, uh, uh, which we give to the Databricks BG Largen, this is a large English model which has a really good score on producing quality outputs with English prompts. So I use this one, and then it generates the retrieve chunks. Now, even if I ran this just a few hours ago, so if you see, I just asked the question like, what's the threshold for filing a currency transaction report? You might have seen this in the demo. That's using routing which one to route. But if I have to test this, just smoke test, if it's not running as a module, it says this is the thing which comes from the policy documents and like exceeding $10,000 and multiple cash transactions by a single business, which ideally comes from the policy document. Uh, if we go to the SQL agent, as you see here, I have fixed SQL queries, which are technically hard-coded SQL queries because these are fixed violation which we need reporting on a daily basis, and they also generate data. And this is a text to SQL agent. So if you see here, so I fixed the like catalog schema and the endpoint and giving it hints like known categorical values, cash deposit, all these are hints. And I gave it a system prompt. You're a text to SQL analyst assistant for ML compliance working on this. So these are the rules. Return exactly one statement and nothing else. Generate a read-only select query, never insert, update, select merge. Use only fully qualified table names, because for Unity Catalog we need catalog.schema.table name, and use only the tables and columns provided in the schema. So none of the columns are assumed. It comes from the schema. And these are the extra. Also, I gave a rule that wrap the query in a single code block rather than giving multiple 3 4 queries in a single, because it should query against the database and produce results again. Now if you see here, I've also added forbidden rules, which says insert, update, delete, merge. All these are forbidden, and then these are additional rules which says multiple statements are not allowed, so that we provide context to the LLM. Then with these, I add a system message, user message, and then ask the model a question. So if I ask the question model a question, you know let me just run this. Let's see how it runs. So you see, these are the model questions I asked, like what is the high risk customer? It says this is the select query. So this tool, so these are all tools. So this tool does just one job, which is text to SQL. It converts this to a SQL query. And answer also, it gave it in a text format. That's about it. I hope that answers your question. John, I see a question is, are there any chances that the model could hallucinate while responding to the request? Yes, definitely. I would say it might hallucinate while giving response, and it can hallucinate. But honestly, for this level of a demo where we have very controlled and very small, like maybe I have few tables and few like a policy document which is 10 pages or 20 pages long. So I would not say, I haven't seen that, because the testing scope here is limited, but I would definitely take into consideration and see what we can, how can that be avoided. Does that answer your question? All right, that is the end of the demo. Thank you. Yeah, John, please go ahead. You're on mute. You're on mute.
Okay, thank you. So the way that you put installed the queries in the code, that means you are limiting the the type of the scope of the questions that users
Yes,
can ask.
yes. So the whole point here is, when we know that the SQL agent need not do any of the CRUD operations, if I don't give that rule, I'm giving it free hand to do whatever it wants. So definitely, I'm stopping it from doing all of those things.
So, so what is
I
the
think those context rules definitely form the most important part. Otherwise, as you said, the hallucinate can happen, and it definitely produces wrong responses. Also, just that I'm not, so I'm using the existing LLM models to solve a problem rather than build a whole model on top of that, right? So these rules come in handy to stop that part.
yes? Now here comes my dummy question. So in this case, what's the difference between having that and just building a dashboard because you already know which type of question will be asked?
Can you repeat the question?
So as I'm saying, in this case, so what is the
Mhm.
difference between just building a dashboard
Okay. So
asking
does
people to ask already known questions?
No. It's a fair question. I started the presentation with the same thing that dashboard doesn't provide you context on why this is a violation, whereas this agent looks up the policy. It's not just querying. Even if you see the violation sweep, it has three set of queries for the limited data we have. Now, is it only giving response of what we have as a select star, or is it also giving the context with the policy data we have? It is, even though it's a fixed SQL query, it is giving me a, a connection between the policy that exists somewhere and also the fixed queries that I wrote. So that's the whole point, which does not be generated in a dashboard, right? You're on mute again.
Yeah, I was saying sounds good to me. Thank you.
Yeah, I mean, like, this is a starting point where, a lot can be done using this, but this is just a starting point.
Interesting.
Yeah.
I think we have one more question in the chat by Asim.
Okay, so does the agent always go for fixed sweep for the prompted question? Then if it is not able to find the answer, then it uses text to SQL tool. So while routing the agent, we provide context with fixed examples like giving keywords. Okay, if it's a violation, if it's a structuring related question, route it to fixed sweep. If it's a generic question like what are the top five, let's say, what like let's say what is the average deposit amount for this country, that's something text to SQL, because that's an ad hoc query. But if we have defined, let's say in my example I've defined three different use cases where CTR is one violation, structuring is one violation, and OFAC in one violation. Now those questions, let's say even though 100 questions can be asked, some of the keywords match, right? So we do that keyword matching and say, okay, if these keywords are mentioned, try to get an answer with fixed sweep. If that does not work, then it goes to this. And if those keywords do not match, then it will directly go to text to SQL and combines it with policy and gets out the answer.
Okay, got it. Thank you.
Do we have any
John,
other questions? Yeah. If anyone has some questions, any comments, please feel free to unmute or write in the chat. I think we are good, Siva.
thank you. I'd like to say I'd really like to thank you guys for organizing such an amazing cohort so that everyone can learn and contribute. This is amazing learning experience for me as well, presenting here and also responding back to the questions, interesting questions that everyone has. Uh, Looking forward for the next month, and I'll definitely join. And I'm just sharing my LinkedIn over here. I definitely like to hear any opinions or any feedback for that matter, because I'm not an expert in AI. I would say no one is an expert in AI. Everyone is learning. So please feel free to send a request for a coffee chat. I'd like to meet anyone who wants to meet in Toronto. Thank you.
Awesome. Thank you so much. I'm going to stop recording now.